Friends, welcome to my channel. I'm in coaching center. Today I'm going to explain you 10th standard science chapter 5 period classification of element. So as you know, at present there are 118 elements. Present there are 118 elements in the word, 18 elements in word at present, and the scientist has classified and arranged this scientist has classified and arranged this element, classified and arranged this element and the scientist has classified and arranged these elements in order of Chow's early arrangement. So early arrangement and classification of the elements, early arrangement and classification of elements. So let's know about this. Can be even the elements can be arranged on their properties, on sorry arranged can be arranged on their properties. We can arrange it even like that. Scientists has tried to arrange the element. Scientist has tried to arrange the element. They tried to arrange the element element with their properties, with what properties they have, like that they arranged in the shows, in the shape of shows. They arrange the element as two types. In two types they said that element that are metal and non-metal, metal and non-metal. And now we are getting knowledge. Now we are getting knowledge about the properties, about their properties and other things. So Dauber and Trade. So Dauber and Trade is a German scientist called as Dauber. He arranged the element that have the same properties. So he saw some group having three elements. He saw three elements. He saw that, and he said that he called this as trade. It's written in the increasing atomic mass. They are written, and the atomic mass of middle element. Atomic mass of middle element is the mass of the atomic mass of the middle element. As I said, there will be three elements. In that, the first element, atomic mass of the middle element, is the atomic mass of other two element. Average atomic mass of other two element. The average we get of the atomic mass of other two elements. As I said, there will be three elements. In middle elements, if we do first and last elements average atomic mass, then we will get the atomic mass of the middle element. For example, lithium. Li, and sodium Na, and potassium K. Potassium atomic number. And the atomic mass number is 3 9, 2, 3, and not 6, 1 minute 6, and they have total average number is 39 we will get. So this is atomic mass. So it was not successful because the brainer could not make traits of all elements present at that time. The elements that were present at that time all were not making fit in the atomic mass of the, as I said, trade means you should put 3 only. The atomic mass was and the properties were not similar, so he can't be able to put that, so it was a failure. After that, Newland's law of octave Newland's law of octaves. Let's know about this. So Newland, an American scientist, he arranged the elements in the increasing atomic mass. He arranged that elements. He arranged the least number, the lower element, that was hydrogen, that has less elements, or that is in lower. He arranged that, and the least is, and the highest is the thorium. He arranged the highest element that was found at that time. So what he did means, he said that all eight elements in this, he arranged in that all 8 elements shows the similar properties of first element in that, properties of their first elements similar. All the 8 elements shows the similar property of the first element, and this is called as Newland law of octave. And sodium is the eighth element after lithium, and they both shows the similar property. They both shows the similar property they both shows. So were there for them. So it was found that, they found that it was only applicable, this land of octaves, it was only applicable till the calcium element. It was applicable. After that every 8 elements, after that, as he said, every 8 elements he was joining, every 8 elements were not showing similar property of first element. As I said, the every 8 elements should show similar properties of first element. They were not showing, so it was a little failure. So it was said only 56 elements are there at that time. No, 118 elements are there, and no new element could be discovered. They said that no new element could be discovered. They said could be discovered, but new element discovered in future. As you know, now from 56 now 118 elements are there, so new element were discovered till now. So It was also a problem how to put the elements. So to put the elements in that, to put the elements in Newland period table. Well, he adjusted two elements. So that time two elements they got. He adjusted two elements in the same slot. He put it same slot, but it was not correct. But it was not noted, or it was not correct. That cobalt, nickel are placed in same slot as he placed two elements. So cobalt and nickel are placed in the slot of chlorine. On that chlorine in this it is placed chlorine, but it does not show the same property. It does not show the same properties. It does not show, so it is wrong. After that, noble gases were found, and new law of octaves was stopped. It was stopped. Next, who came is after is Mendeleev's periodic table. Of curvature, radius of curvature is 2 times of focal length, that is focal length. So radius of curvature r is 2 times of the focal length, we can say that, because in the middle it will come, so the 2 times. If in middle spherical mirror will come, so there will be 2 times of focal length we will get the radius. So we can write it as r is equal to 2f. We can write it 2f. Now image formation in spherical mirror. So for that we have to tell the size. What is the size? It is bigger than object, or it is the same size of object. And the formation size of the image, position and nature of the image. We should tell to find that. So this photo will tell you the image or the position, in which position if the object is placed. So position of the object, if it is on focal length or f, then the size of the image is highly diminished, or it is little bit blur. And the nature of the image, what is the image? It is real. The image is very much real, and it is little bit inverted, they will say. And if the focal length, if the position of the image of the object is beyond c or center of curvature, then the position of the image, where the image will come, means in between the f and c, means focal length and between the center of curvature, the image will be formed, and the image will be very much diminished, and it will be real only. And at c, if the image is placed at c, not beyond the c, at c only, then the image will come at the c only, and the size of it will be same size. The image will be same sized. And if it is between the c and f, the image is placed in a concave mirror. If between c and f, means the image will come beyond the c. It will be coming, and it will be enlarged, means it will be big. The image will be big, and it will be real. Like at f, and between p and f. At f means the image will come at finite, any place it will come, and it will be highly enlarged, very enlarged it will be, and real. And at p and f, principal focus or focal length, p and focal length, and pole. If at pole and focal length, if the image is placed, then it is behind the mirror or enlarged. Next is representation of image. Next is representation of image on spherical mirror. Representation of image on spherical mirror, or spherical mirror means concave mirror, and convex mirror by ray diagram. By ray diagram we are telling that whether it is falling on P or beyond P. So this is first ray diagram. So the in is concave mirror. In A it is showing A. This one it is concave mirror. So concave mirror, so a light or a ray of light is coming from from an object, and it is touching the concave mirror, and it is hitting the concave mirror, and it is inverted. It is getting inverted and joining through focal point, or the principal focus also they call focal length of principal focus, in the first mirror. And in the second convex mirror, a light is coming and it gets inverted, but in here inside it joins the focal length and the center of curvature, both it joins. Mendeleev, who was a Russian scientist, he arranged the elements according to atomic number, mass, chemical properties, and all that he is seeing. He arranged them. At that time 63 elements were there. So he took oxygen and hydrogen and arranged the elements on that. He took cards and wrote the elements name, atomic mass, properties, what are the properties it has. He wrote that and arranged them in the elements which shows same property, arranged them properties, and made periodic table. Mendeleev's periodic table consists of periodic table has vertical column called groups, and horizontal column called periods. The Mendeleev's periodic table. So achievements of Mendeleev's periodic table. Achievement of Mendeleev's periodic table. So what achievement he did, the Mendeleev's periodic table did. So he placed the two elements that shows similar property, properties in same column. In that column only is he put it. He left the gaps. So here you can see in this periodic table he left some gaps. So he left the gaps for the elements. That are discovered in future. So if there's the elements are discovered in future, for that he left the gap in that. He also left gap for noble gas. He left gap for noble gases. Limitation of Mendeleev's periodic table. Limitation of Mendeleev's periodic table. periodic table. So what limitation he had means the hydrogen, like alkali metal and alkali metal hydrogen, they both hydrogen combines with halogens oxygen, and they have similar formula was no fixed position for hydrogen. There was no fixed position for hydrogen in Mendeleev's periodic table. And also now also isotopes were discovered after making of Mendeleev's periodic table. Mendeleev's periodic table. After making this, the isotopes were found. So here I will stop. I will explain the next topic in my next video. So okay friends, like the video, comment on my video and subscribe my channel. I'm coaching for more videos. I will explain the next topic in my next video. Till then, take care and have a nice day friends. Bye friends.